So this lesson is applying exponential functions to real-world problems. Now, here's the thing. We have exponential growth models that can be written a little differently than you've seen. And here, the A value is your initial amount, right? Now, your T is time, right? Your R is your rate of growth. And then when you look at the 1 plus R, that's your growth factor. Now, when we look at this, right, where does exponential growth come in? So in 1990, you bought a house for 120,000, and houses in the neighborhood have appreciated or gone up in value approximately 4% per year. How much will it be worth in 1993? So when we look at this, right, we're going to say 1990 is year zero. So we're going to go the long way and start this out. So if we did 120,000 times 0.04, remember, 4%, when you calculate it, you have to divide it by 100 to get 0.04. So 4% of that would be $4,800. And now the new value would be 120,000 plus 4,800 would give you 124,800. But now when we go to the second year, this would be 1991, or say the first year, right? You would do the 124,800 times 0.04. So now your house went up $4,992. And if we take 140 or 124.8 and you add the 49.92, that would give you $129,792. Now, to find the value in 1992, right? Now I'm going to take the new value, 120,792. I'm going to multiply that by 0.04. That would give me 5191.68. And if I take and add the two values together, the new value of the house would be $134,983.68. And when everything's said and done, when you do it one more time, in 1993, the house would be $140,383.03. So what you guys have to understand is multiplying by 0.04 and then adding it. If you were to take your calculator, right, and do 120,000 times 1.04, that would give you 124,800. Okay, and it's key to know that that's basically 104%. So you're basically going up 104% of the new value each time. So if we were to write an exponential function for this, we would say f of x equals, what was the amount, initial amount? 120,000 times 1 plus the rate. Our rate was 4%, and when we convert that to a decimal, we would get 0.04. So 1 plus 0.04 to the x power. Okay, and we would just simplify that and say f of x equals 120,000 times 1.04 to the x power. So if you wanted to retire in 2010, how many years after 1990? If 0 is 1990, how many years later is that? Well, 2010 would be year 20. So now I can plug that in there. F of 20 equals 120,000 times 1.04 to the 20th power. And this would give me 200, oops, sorry, not 200. $262,934.78. Okay, so Know and understand that when it's appreciating or going up in value, we use 1 plus the rate. Now, exponential decay, when it goes down in value, again, your initial amount is always going to be A. R is going to be your rate of decay here. T again is time. And then 1 minus R is your decay factor. Now, if we were to calculate this again the long way, because it's decay, we're going to figure out the percentage and then subtract it. So it says Bob bought a used car for $12,000 in the year 2000. It depreciates or goes down in value at a rate of 15% per year. So that means in 2000, the value of that car was $12,000. In 2001, we would take the 12,000, multiply it by the 0.15, and that would give me $1,800. And now if I take the 12,000, subtract 1,800, in 2001, that car would be worth 10,200. In 2002, we would take the new value, 10,200, multiply it by 0.15, that would give you 1,530. And now if I take 10,200 minus 1,530, the new value would be $8,670. So if we were to go and continue and do this one more step, in 2003, right, this would have a value of $7,369.50. Now, what you have to understand is if we're deducting 15% each time, what we're basically doing here is 1 minus 0.15 would be 0.85. So if I were to take 12,000 and multiply it by 0.85, that would give me 10,200. So it would go straight to calculating that number. So the reason when we have exponential application problems that deal with exponential decay, what we use is 1 minus the rate. So here, if I wanted to figure out, right, a model for this situation, it would be f of x equals, what was the initial amount? 12,000 times 1 minus, remember, 15% is a decimal, is 15 divided by 100, which is 0.15. So 1 minus 0.15 to the x power. And we would simplify it one more time, saying 12,000 times 0.85 to the x. So if we wanted to find the value of the car 7 years later, we would say f of 7 is equal to 12,000 times 0.85 to the 7th power, which would give me $3,846.93. Okay, so let's kind of go through this in a few more examples. It says here, a new snowmobile costs $4,200. The value of it decreases by 10%. So right there, you're using decay, and we're going to use 1 minus r. So we're going to actually write this function and go to b first. So the function would be f of x equals my initial amount, the 4,200, times 1 minus, remember, 10% divided by 100 is 0.10. So times, or 1 minus 0.90 to the x power. And I would simplify this as f of x equals 4,200 times 1 minus, oh, excuse me, sorry about this, 1 minus 0.1, which ends up being 0.90 to the x power. Sorry, I did 1 minus 0.90, and this would be 1 minus 0.10. So use this function model to find the value of the snowmobile after 5 years. So I'm basically going to let x equals 5. So f of 5 equals 4,200 times 0.90 to the 5th power. And if I plug that in the calculator, right away I would get a value of $2,480.06. For example 4, a recent college graduate accepts a job at a law firm. The job has a salary of $32,000 per year. The law firm guarantees an annual pay increase of 3%. So it increases 3%. So we're going to use growth, which is 1 plus the rate. So the function model here is going to be f of x equals the starting pay of $32,000 a year times 1 plus, remember, 3% is a decimal, is 3% over 100, which is 0.03. So 1 plus 0.03 to the x power. So we would simplify that by saying 32,000 times 1.03 to the x. So now to figure out the graduate's salary after 5 years, we would say f of 5 equals 32,000 times 1.03 to the 5th power, which would give me an approximate salary of $42,893.14. Okay, last two problems. Jessica opened a bank account, earns 2% interest compounded annually. So if it earns, that means it's going up. Her initial deposit is 100, and she uses her expression 100 times x to the t to find the value of the account after t years. What is the value of x in this expression? So since we're earning, we know it's growth. So we know it's going to be 1 plus the rate. If the rate is 2%, 2 divided by 100 is 0.02. So 1 plus 0.02 would be 1.02. And last one, the world's population has grown at a rate of 1.9%. There are approximately 4 billion people. So I know right away this is going to be exponential. So I know I'm starting with 4, but you have to understand it's going to be 1 plus the rate because it's going up. 1.9% divided by 100 is 0.019. So 1 plus 0.019 would give me letter A. Go ahead, do the homework, and let me know if you have questions.